Hi everyone. So this is our look at alkyl halides. This is just a small step forward for us, and it's a way to introduce a new type of branch. It's where one of the halogens is going to become a branch on our organic compound. It might be an alkane with one of these branches, an alkene, an alkyne, a cycloalkane, cycloalkene, cycloalkyne, even an aromatic or an alcohol could have a halogen included as one of its branches. If it is one of these branches, it's called an alkyl halide. It's like a branch, an alkyl group, but it's a halogen, but it's not quite, it's a halide. We're going to follow the rules for each specific type of compound. So it does make a difference if we have an alkane or an alkene, for example. We're just going to follow those rules. But now we have four different possibilities now for these new kinds of branches. If fluorine is acting like a branch, we'll call it fluoro, chloro for chlorine, bromo for bromine, and a little bit strange, iodo for iodine. We're going to follow our normal rules for naming branches, only now we have these four new possibilities. What are those rules again? If we have the same kind of branch twice, say di. So we might have difluoro or dichloro. If there's three of the same, then we say tri, as in trifluoro or tribromo. If we have different kinds of branches, we're going to name them alphabetically. Bromo would be the first one, then chloro, then fluoro, then iodo, then methyl. We can see ethyl or methyl in combination with these, so we really have to be conscious of naming them alphabetically. We have to use numbers to show the location of these, just like regular branches. Try and make those numbers as small as possible. So here's a few examples. The first one is an alkane. Second one is an alkene, and the next one is back to an alkane. We're going to use our normal naming rules, only now we have these different kinds of branches. Here in the first example, you have single bonded carbons. That means ane. We need to find the longest chain. 1, 2, 3, 4. It's a 4-carbon chain. 4 is bute. We have butane. Now we have this branch, it's an F. We're going to call a fluorine branch here fluoro. Fluoro. Please notice there's a U in there, it's like fluoro, fluoro. Spelling isn't a huge thing, but you might as well try and spell it correctly, fluoro. Now we're going to need to use a number now to show the location of this fluoro. In contrast to what we saw with a methyl or an ethyl as a branch, we said that we can never have a methyl attached to the first carbon of the chain because it just extends the chain. We would be counting the longest chain around a corner or something like that. But here, the fluorine can be on the end. Clearly here, it's 1-fluorobutane. A second example. I see the double bond. So, ene. Remember, all single bonds, ane, a double bond, ene, a triple bond, ine. Now, we need to show the location of that double bond using a number. Well, it could be in the first spot or the second spot if we count this way, or 1, 2, 3, 4, 5 if we count the other way. Clearly, we get a smaller number if we count in this direction, which is on the second carbon. 2-ene. Now, how many carbons in the chain? 1, 2, 3, 4, 5, 6, 7 carbons in the chain. Don't forget to count that first carbon. You might want to put dots on the ends of the lines or the corners to show those carbons. 1, 2, 3, 4, 5, 6, 7. So we're going to use a prefix for 7, hept. The parent chain here is hept-2-ene. Now we have this branch. It's Br. It's bromine, but we're going to call it bromo. We have bromo hept-2-ene. Finally, we need to use a digit to show the location of the bromine. We're already committed to counting this way. We've already decided that the double bond is in the second spot, so let's just keep counting. 1, 2, 3, 4. That bromine is attached to the 4th carbon of the chain. The name of this compound is 4-bromo hept-2-ene. It doesn't exactly roll off the tongue, but there's a logic to it. We have a double bond in the second spot. Out of 7 carbons, there is a branch. It's called bromo, and it's attached to the 4th carbon. 4-bromo hept-2-ene. One more example. I see single bonds. No double, no triple, single bonds. This is an example of an alkane, ane. A-N-E. How many carbons? 1, 2, 3, 4, 5, 6, 7. Oh, it's 7 carbons again. It's hept is the prefix. The parent chain here, the root chain, is heptane. Let's think of what we have now. We have this branch, which is fluoro. It starts with F. We have 2 iodine branches. It's iodo for iodine, but we have 2 of them, di-iodo. Very strange to have 2 I's in a row in a word, di-iodo. But we need to deal with these branches alphabetically. We have F and I. We need to do it alphabetically. F comes before I in the alphabet. So the fluoro comes first. Now we need to use some numbers to show the location of all 3 of these branches. We're going to get smaller numbers if we count this way. These branches are closer to the left-hand side, so we'll get smaller branches that way. We have 1, 2, 3. On the 3rd carbon, we have the fluorine attached there. 3, fluoro. And right next door, 1, 2, 3, 4 is where the iodines are, but there's 2 of them, and each branch must have a number. So this is 4, 4. Di-iodoheptane. 3 fluoro, 4, 4, di-iodoheptane. We have single bonded carbons, 7 of them. Is there a branch? There's iodo. How many iodos are there? Di. There's 2 of them. Where are they? The first one's on number 4, and the second one is also on number 4. There's another branch, fluoro, and it's on the 3rd carbon. 3 fluoro, 4, 4, di-iodoheptane. These examples, I had 2 where we were following alkane naming rules, and one where we were doing alkene naming rules. It's equally possible we could have an alkyne or a cycloalkane, a cycloalkene. Any of the classes of compounds that we have encountered so far could have halogens incorporated into them as branches. Alkyl halides. And I hope that helps.